Welcome to the deep dive. We're the place that tries to cut through the noise on complex tech topics and really find those key insights. Today, we're looking at something that's, well, pretty fundamental if you're working with Kubernetes, config maps. Might sound a bit technical, maybe, but I hear they're actually super practical, really powerful for modern apps. Our mission then is to unpack how these config maps work, figure out why they're so essential, and see how they genuinely simplify managing applications in K8s. We're basing this on some great material, specifically ConfigMaps, Kubernetes Configuration Management Essentials.
Absolutely. And it's more than just knowing the definition, right? Getting config maps is, I'd say, a foundational step. It's really key if you want efficient, scalable deployments. It gives you that flexibility and, honestly, helps avoid getting swamped as things get more complex.
Okay, so let's dive straight in then. At its core, what is a config? Can give us a quick version.
Sure. Think of a config map as basically a dedicated box inside Kubernetes. Its whole job is storing configuration data that isn't sensitive. So things like environment variables, maybe connection details, sometimes even whole config files. And it stores them externally, away from your actual application code, usually as simple key value pairs.
Okay, key value pairs external to the code. That decoupling sounds like the main idea.
Exactly. That's the core benefit. It lets your applications grab these settings without needing any code changes.
You really stress non-sensitive there. Why is that distinction so crucial for anyone new, maybe?
Yeah, it's a critical security point. Config maps are specifically for data that doesn't need tight security. If you've got passwords, API keys, the really sensitive stuff, that's what Kubernetes secrets are for. Using a config map for secrets is a huge anti-pattern. It's like, well, leaving your keys out in the open. Secrets offer better protection mechanisms, like potential encryption at rest.
Got it. Big difference. Don't mix them up.
Yeah.
Okay, so stepping back, you said they're foundational. Why do they even exist? What problems are they solving?
Right, so the why. It really comes down to solving operational headaches. First big one is separation of concerns. By keeping config outside the CKAD, you avoid that whole cycle of rebuilding your container image just to change, say, a logging level. It makes you much more agile.
Ah, okay, so faster updates, less rebuilding. That sounds like a win.
Definitely. Then there's portability. You can have one container image
Right.
and run it in dev, staging, and prod. Config maps let you inject the right settings for each environment. The same image just adapts.
That's powerful. One image, multiple environments.
Yeah. And that links to flexibility too. Kubernetes gives you different ways to get that config map data into your pods, environment variables, command line args, even mounting them as files. Lots of options.
Okay.
And finally, reusability. One config map can be used by lots of pods. Maybe all the pods for one microservice use the same config source. Keeps things consistent.
Right. And just to quickly recap some terms for folks, pods are where your containers actually run. The cluster is the whole Kubernetes environment. Kubectl is your command line tool to talk to it all. And the API server is like the central brain processing your requests.
Exactly. And config maps fit right into that picture. They're essential for managing application settings cleanly and scalably within that Kubernetes model.
Okay, great groundwork. We know what they are, why they're important. Let's get into the mechanics now. How does Kubernetes actually handle them? How do they work?
So under the hood, they're pretty simple data stores. Key value pairs, mostly, stored in the data field of the config map object. There's also a binary data field for binary stuff, but data is way more common for text configs. The real magic, though, is how pods use this data. Kubernetes has several ways to inject it.
Okay, what are those ways?
Well, the most straightforward is probably as environment variables. Each key value pair in the config map can become an environment variable right inside your container. Super simple for small settings. Or you could use the values as command line arguments when the container starts up. Useful for things that need to be set right at launch.
And you mentioned files earlier. That sounds really useful too.
Yes, that's often the most flexible. Mounting config map data as volumes. This makes the keys and values in your config map appear as actual files inside the container's file system. Perfect for things like, say, an Nginx config file, or any app that expects its configuration in a file format.
Ah, so you can literally mount a whole config file that way.
Exactly. And another important point, config maps live within a specific Kubernetes namespace. This gives you isolation. Different teams, different environments, they can all have their own config maps without stepping on each other's toes.
Right, namespaces for separation. Good point. What about updates? How does that work?
You update config maps using Kubectl, just like creating them. The change gets stored in Kubernetes. But, and this is important, how your pod picks up that change depends on how you injected the data.
Okay.
Environment variables often require a pod restart to pick up new values. Volumes mounted from ConfigMaps are a bit trickier. By default, the mounted files don't update automatically inside a running container. You usually need to restart the pod or have some mechanism in your app to reload the config file for the changes to take effect.
Ah, okay. So updates aren't always instantaneous, especially for volumes. That's a key operational detail.
Definitely something to plan for. Now, if you actually look to the YAML file for a config map, the structure is pretty clear. You'll see APA version, usually v1. You'll see kind config map, then metadata, which has the namespace it belongs in, maybe some labels for organization.
And the actual configurations.
That's in the data section, just key dot value pairs, like database.host, like mysql.prod.svc.cluster.local, or log.level.info. And as I mentioned, there's an optional binary data field too, but it's less common.
Okay, so connecting this back, why does this structure and these mechanisms matter for the bigger picture?
Well, it all drives those benefits we talked about. Maintainability is huge.
Mhm.
Central config means easier updates across maybe hundreds of pods. Environment flexibility, that ability to run the same code everywhere just by swapping config maps, that's massive.
Yeah.
It supports scalability because you can share configs easily across the large cluster. And fundamentally, it ensures consistency. All pods using that config map get the exact same settings, reducing weird, hard-to-debug errors.
Can you give a really simple, concrete example?
Sure. Let's say you have a web application that needs to know the URL of your database. You create a config map, maybe called web app config, with a key like db_url and the value jdpc.mysql. Then, in your web server deployment YAML, you tell it to inject the value of db_url from the web app config map as an environment variable called database connection string. Now, every web server pod automatically gets that environment variable set correctly. If the database URL changes, you just update the config map, maybe do a rolling restart of the pods, and everything points to the new location.
Right, that makes it very tangible. One change ripples through consistently. Okay, let's talk practical uses. What are some common use cases where config maps really shine?
Well, loads. The most obvious is probably environment-specific configuration. We touched on this. But yeah, having different config maps for dev, staging, prod, maybe API.endpoint points to a test service in dev, but the real one in prod.
Right, like the log level example you gave earlier.
Exactly. A single container image adapts because the environment's config map provides the right settings. No need for environment-specific code or images.
Makes sense. What else?
Centralized configuration management. Think microservices. You might have several services that all need to know, say, the address of a shared caching layer or an authentication service. Put those common addresses in a config map. All the services reference it. If that address changes, you update it in one place. Cuts down duplication, prevents inconsistencies.
Yeah, I can see that being crucial in complex systems.
Yeah.
And the file mounting.
That's the configuration files use case. Super handy. Got a complex nginx.conf for application.properties file. Just put the entire file content as a value under a key in your config maps data section. Then mount that config map as a volume into your container, telling it to create a file, say nginx.conf with that content.
So you can manage entire config files through Kubernetes objects.
Precisely. Update the config map, potentially restart the pod, and the new config file is active. No image rebuild needed just for a config tweak.
Okay, that's clever. Any other big ones?
Feature flags are a really interesting one. You can use a config map to control application behavior on the fly. Maybe you have a key like enable beta feature, true or false. Your application code reads this value, maybe on startup or periodically, and enables or disables that feature accordingly.
Ah, so you can toggle features without deploying new code.
Exactly. Great for rolling out changes gradually,
Yeah.
A/B testing, or quickly disabling something if it causes problems. Gives you runtime control.
That's very cool. Okay, so we see the uses. How does this all fit together with the main Kubernetes parts? You mentioned kubectl and the API server.
Right, the interaction flow is pretty straightforward. You, the user, define the config map in a YAML file. Standard Kubernetes practice. You apply it using kubectl, apply -f your -configmap.yaml. That sends it to the API server. The API server validates your YAML, makes sure it's correct, and then writes it into, etc., Kubernetes' distributed data store. That's where the cluster state lives.
Okay, so it's stored centrally. How does a pod get it?
When you define a pod in its YAML spec, you reference the config map. You say, I need this key from that config map as an environment variable, or mount this config map as a volume at this path. When the pod is scheduled onto a node, the kubelet, the agent on that node, reads the pod spec, sees the ConfigMap reference, talks to the API server to get the ConfigMap data, and then injects it into the container as requested, either setting up envars or mounting the volume before the container starts.
So the kubelet does the actual injection work on the node.
Correct. And for updates, you'd use kubectl apply again with the changed YAML, or maybe kubectl edit ConfigMap. This updates the object in etc. via the API server. And like we said, pods might need a restart to see those changes, depending on the injection method. You can always check the status and data using commands like kubectl describe configmap or kubectl get configmap OYAML.
Got it. So if we boil it down, why are config maps so effective? What are the core wins?
I'd say it's four main things. Decoupling.configuration lives outside the code. Huge for maintenance and portability. Flexibility, multiple ways to inject data, NV vars, args, files, pick what fits. Reusability, share settings easily, reduces duplication, and ensures consistency. And automation fits perfectly into the declarative infrastructure as code model of Kubernetes. Manage config just like any other resource.
Okay. Before we wrap up, any best practices people should keep in mind when working with config maps?
Definitely. A few key ones. First, use descriptive names for the config map itself and the keys inside. Database URL is much better than dview.
Yeah.
Makes things understandable.
Makes sense.
Scope to namespaces. Use namespaces to isolate configs for different apps, teams, or environments. Prevents clashes.
Crucial for multi-tenant clusters.
Absolutely. And I'll say it again. Always use secrets for sensitive data. Config maps are not for passwords or tokens. Seriously.
Heard loud and clear.
Also, try to minimize updates if possible, especially for volume mounts, because of the restart implications. Plan your updates. Be mindful of the size limit, too. Config maps aren't meant for huge blobs of data, usually around 1 MB max.
Good point on size.
And finally, version control your config map YAML files. Treat them like code. Store them in Git. Track changes. Enable rollbacks. It's just good practice for infrastructure as code.
Excellent advice. Okay, I think that really gives us a solid understanding. So bringing it all together. Config maps are Kubernetes' way to handle non-sensitive configuration externally. They let you separate settings from code, making apps portable, maintainable, and flexible. You define them declaratively in YAML, and Kubernetes injects the data into your pods as environment variables, arguments, or files. Really powerful stuff.
Absolutely. And maybe a final thought to leave you with. Given how ConfigMaps streamline this one aspect application configuration by decoupling it and managing it declaratively, how might that core idea, that pattern of separating data or state from the thing that uses it, apply elsewhere? Think beyond just app settings. How could this concept of decoupled declarative management help simplify other complex parts of managing distributed systems? Something to ponder.